Welcome all. So in this video I'll solve all the week 2 questions with explanation. So week 3 will be a little bit tougher. We'll cover in the next week, in the next video. So the first one they are asking to compute the minimum edit distance of length m and m using dynamic programming. So the option is option D. You can refer the lecture notes of week 2, so it will be given in the page number 60. The second one, consider a bigram model. Vocabulary size they are given. You encounter a bigram of smartphone which appeared 0 times and the word smart appears 500 times. So formula is there, that is P. So this P add minus 1, which is equal to count of smartphone plus 1 divided by count of smart plus the vocabulary value. So which will be smartphone appears 0 times. So probability of phone given smart means you have to calculate the count of smartphone divided by the count of smart. So in the formula additionally we will be having the vocabulary term. So the numerator is 0 times, that is smartphone. Smartphone occurs 0 times. 0 plus 1 will be coming in the formula. You can refer the notes. Divided by count of smart 500 times. So 500 plus vocabulary size is 10,000. So the answer is 1 by 10,500, which is option C. So then the third one. So in the context of spelling correction, how are non-word errors distinguished from the real world errors? The answer is option B. You can refer the notes, page number 104. So coming to the next one. Once again they are given a string here. Identify the following set of strings as a Levenshtein distance of exactly 1. Levenshtein distance or minimum edit distance, that is 3 things you have to consider. The distance should be is equal to 1, exactly is equal to 1. Insertion, deletion and substitution. If you are checking the option C, the first one I will be deleting the word B-R-E-A-D. If I delete the word B, I will be getting read. Then instead of E, if I substitute O, I will be getting board, B-R-O-A-D. Then once again the substitution, instead of B, I will be going for D. Then deletion, if I delete A, I will be getting B-R-E-D. If I delete R, I will be getting B-E-A-D. So the option is option C. Option C. I am having they are given a trigram language model of n is equal to 3. If you are applying the Markov assumption, so normally if trigram is given means you can calculate it as n minus 1. that is two words. If it is a bigram means I will be getting only one. The option is option C. Once again the Levenshtein edit distance. So they given two words, brisk, brick. On seeing the word itself, you can say that. So summing a cost of 1 for insertion, deletion and substitution, what is the minimum cost they are asking? The only thing that is changed is instead of S, it has been substituted as C. So cost is equal to 1. The option is option A, substitution. So what the seventh question is, what is the primary motivation for applying Laplace add-one smoothing to n-grams models, generally to handle the zero probability problem? Option B, you can refer the notes also in the page number 102. Then the next one will be, they given three sentences, three corpus or sentences, three corpuses, three sentences. For the next two questions they are given. First we will calculate one by one using the maximum likelihood estimation MSE. As I told, they are asking the probability of log given d. Log given d means which is equal to count of, what is the value? The log divided by count of d. Additionally to this, in the fourth problem we will be having +1 here and vocabulary terms will be given at the, will be coming at the denominator. Here we have to calculate only the count of d log divided by the count of d. So d log will be appearing two times, d log, and count of d is 1, 2, 3, 4, 5, 6. So this probability of log given d, which is equal to 2 divided by 6, I will be getting 1 by 3. So the option is answer B. So perplexity, the next one, perplexity denotes the inverse probability of the test data. So you have to calculate the bigram model, probability of bigram model, then only you can calculate the inverse probability. The same thing, the same formula, the bigram model, but here they given the sentence as the cat sat. So first we have to consider the, first you have to calculate the probability of the cat, then we have to calculate the probability of cat sat. So once again I am applying the same formula. So the first one is, you have to calculate the probability of the bigrams for the cat, that is will be writing as probability of cat given d. So just count down the cat given d means count down the probability of, sorry, count the words of the cat divided by count the value of the. So the cat is, you can go to the sentence 1, 2. So the cat value is 2 divided by count of the, already we have calculated, it is 6. So the probability of cat given the is equal to 2 by 3, which is nothing but 1 by 3. Sorry, 2 by 6 is equal to 1 by 3. Next one, the next bigram, cat sat. So once again, it is probability of cat sat mean sat given cat, which is nothing but count of cat sat divided by count of cat. What is the count of cat sat? 1. So it is 1. The count of cat is equal to 1, 2. So here I will be getting 1 by 2. 1 by 2. And we can multiply both the probability to get the final one. So probability of the cat sat, which is nothing but probability of this sentence, the cat sat, which will be is equal to 1 by 6. If you are applying in the formula, we will be getting, that is perplexity is equal to, I am writing as P, 1 by P sentences, P sentence whole power 1 by n. Here it is bigram, so it will be 1 by 2. So I will be getting 1 by 6 whole power 1 by 2. 1 by 2, which is nothing but a square root. So I will be getting, the option is A, square root. Then the next one, spelling corrections. Once again they edit distance. So D is equal to 5 for deletion, D is equal to 5 for insertion they are given, and for match or substitution they are given as 4. This one, the last one. First one is deletion, second one is insertion, and the third one is, this one is match. So cost for 1 for insertion and deletion, and 2 for substitution, 0 for match. They are asking the minimum value. So if you calculate the minimum value for deletion, it will become 6. 5 plus 1, it will become 6. And for insertion, it is also 6. 5 plus 1, 6. So 5 plus 1, the value, and for the cost, it will become 0. That is 4 plus 0. Match. The last one is match. So out of this, the minimum value is 4. So the option A. Thank you.